Each part of the gull wing lead has a specific name. The tip of the lead is called the toe, and the foot extends all the way to the heel of the lead. If the tip rests on the knee, or the bent part of the leads, the transfer of heat will be extremely slow. After the tip is installed and heated to the selected temperature, we'll need to make sure that it's properly prepared in order to transfer the heat as efficiently and quickly as possible. We start by removing any hardened oxides with a non-abrasive cleaning tool. We will be cleaning all of the tip surfaces, inside and out, wherever the tip will come in contact with the leads. Next, we'll use a dampened sponge cleaning tool that is designed to reach inside these multi-sided tips. This tool will shock any remaining oxides off the heating surfaces. Now we're ready to tin both sides of the tip with solder. We'll be using a large gauge, flux cord solder that is compatible with your assembly process. This fresh solder tinning will speed up the heat transfer and provide surface tension. As an option, we may add external flux to the component leads to further improve the transfer of heat. Now the tip is placed over the component, in contact with the foot of the leads, until all of the joints are melted. When the iron is lifted, the surface tension of the solder will lift the component off the lands. It's important to avoid putting any downward pressure on the tip during the removal process. If you press too hard, you can damage the lands. The weight of the handpiece should be sufficient. Twisting or sliding the tip before complete solder melt can also damage the lands and the component leads. There are also special tips available for removing thin, small outline packages. The technique for removing TSOPs is exactly the same as the SOIC removal process. Small PQFP removal can be performed using four-sided tips. Larger PQFPs will generally be too heavy to lift with surface tension alone. For all multi-leaded components, it's important that you melt all of the leads quickly and simultaneously to ensure a safe removal process. If one or two solder joints don't melt for a number of technical reasons, the component will remain attached to the board. In this case, you may have to apply heat for so long that it causes thermal damage to the board. Rocking the tip to try and melt all of the solder joints can also damage the lands. As the tip is rocked, there is a concentration of pressure along the four edges of the tip.